Okay. Take your notebooks for last day. The bell is gone. Let's move. We're gonna start. You did this, right? And we just didn't get the time to put it up here.
I don't think it's Dan Norman.
Do you know who Mr. Norman is?
Yes.
Oh yeah.
I just googled Dan Norman trading cards.
You'll find a lot of baseball players.
There are a lot of Dan
Yeah.
Normans that play baseball.
Yeah, you got to get rid of the baseball players, and then you'll find him. He looks really intense. On the stream in a kayak, I saw a student like say, "I don't know," and they're like in a little bit of trouble. Like he just zipped over against the current, like choop, picked the entire student up in the kayak and threw him onto the shore with one hand. He's a beast. That's why. Now the student's safe on shore. Yeah. Yeah. Shall we say? Oh, I should do attendance first. We are. I have a new member of this class. Pablo, you're not on here yet because I haven't edited it yet. I should do that. I'll do it after. I'll just put you as the last name.
You can put him as Julie Judy because he's not.
Julie, right, I have to do attendance. What is my brain doing? Attendance. Anders. Caden. Esther. Hillary. Jennifer. Jennifer. Jojo. Julian C. Julian G. Away. Liam. Lucas. Mirhat. Mick. Oliver. Riley. Vienna. I said that weird. Vienna. Thank you. Zach.
He's in ODP.
Oh, he's in. Zach.
He's in ODP.
He's in. Oh, he's away in the Salt Spring. Okay. Toolkit. Group maker. I'm going to make groups of one. That looks good. Pablo, your number is 15. Let's add you to the end. Everybody else, see your number? Write down your number. Everybody got their number? Yeah? Excellent. That is the atomic number of the one you're going to do on the board right now.
I think I was 7.
Yeah, you did it last class. So let's review by putting up the answers. Put them in. What? I did. Okay, what? No, stop. Everybody look. Everybody got their number? No, stop. No. 1 second. No, back away. Back. Has everybody got their number? Okay. Now we can do this.
No, it's hydrogen. I don't want to be hydrogen anymore.
And I'm going to see if I can get my
I think this is
add Pablo.
Jojo, I think you did it wrong.
Huh?
Yours is wrong.
Hold up. Can I look at this?
Wait, is this the iron or no? It is the iron.
Wait, what's the helium? Is helium neutral?
Yeah,
The atomic number is in the upper left. Are you double checking?
Upper left.
Anderson,
Jojo, you got it wrong.
how are you feeling?
Yeah, that's right.
No, I'm not talking about sickness. I'm talking about the material. Do you remember the Bohr model? Valence electrons. So if I said you
Minus
I did it
one.
wrong. I also did it wrong.
This one should be -1.
So on the periodic table,
Column 7.
It's an ion.
What do I do?
So it has to have a complete shell total. So it should be 2 and 8. So it should be an extra.
and it has 4. So how many go in the first shell?
Oopsies.
Yeah.
Thank you.
I need an eraser.
Oh, what's the pattern in shells?
You're right.
You have,
I'm
like,
using an eraser right
number
now.
of protons,
Oh, I did the
and then you have
eraser.
electrons that fit.
Anyone who
You
needs to
know
use the
the
eraser. Wait, don't. It's a erase button now.
You can fit a maximum of 2, and then 8, and then 8, and if you had to go that far, that one's 18. Okay? So the number of protons should equal the number of electrons if it's neutral, because they balance. This is positive, that's negative. Okay? So if you have 4 protons, okay, 4 protons, how many electrons should you have? So we did that on not last day, but the day before. Yeah, you're gonna get up and then drop it.
Step
One's this.
Someone did mine.
Give us that.
Oh, what number are you?
Did this part make sense?
Oh.
Okay. Now what we said, this was last day's work, is that this is a neutral atom, but atoms want to be stable. And stable, you said the word valence. What does valence mean? Outer shell.
Which one's it?
It is stable when the valence is empty
Maybe try
or
to do
full.
4.
And it does that
That's
through
not
the
done.
most efficient way possible. Like which would involve more work. And it wants to do less work. So this is full when it's 8, or it could go to 0. Which would be easier? Taking away 2 or adding 6? Pardon? Do you want to roll 2 boulders away or roll 6 boulders through it? 2 boulders away. So then we say to be stable, you take it away. Now this, and now if you take 2 electrons away, what's its charge? 2. 2 plus. You can always get the charge by taking the number of protons, minusing the number of total number of electrons, and you always get the charge with the right sign as well. So this is the ion because it's plus 2, and this was the Bohr, like a simplified Bohr for the atom. And what we're doing up there is the ion. Okay. You want to go up and fill up the, put that in for number 4? 1, 2, 3, click, you're good to go. So, yeah, this, and then the charge below, just as everybody else is. Oh, right. Where did the spray bottle go? There. Excellent. I don't want you to see that because I'll give you answers. Okay. I think you put it on shape recognition. When you're looking at these pens, you really need to know it. You always want the first one. If you do like other ones, you get weird stuff. Like this is like a weird fancy pen that like has different widths. You can also make it thin. If you pick like that pen, you're going to start highlighting everything. And the most dangerous pen of all are these last pens, because then you can just get like weird things. Or if I start doing notes in the magic pen, you know, these are your notes, you would probably hate that because the magic pen is magic because it disappears. I don't know. It's magic. I mean, I've got crayons. I should write in crayon, actually. I think that's new. Shape recognition pen, that one can be useful. Magic pen. Oh, the magic pen can also do things like this. Like, let's take a really good close look at this answer. And then it should just go, it did nothing. Well, that was useless. Maybe they've changed the functionality. Huh. Oh, they have changed the punishment. Okay, never mind. It's not doing the magic anymore. Okay, go away. Okay, I'm going to check your work. we notice that the number of valence electrons, now we have a little plus there. Those are electrons. We don't quite need another plus. And notice you can, oh, weird. You can leave off the E once we know that for really simple diagrams. So once we take it out, it goes 2, 2, 2. And then at this point, however, it doesn't go 4. If you're minus 4, what did you do? What should that number be? 8. Now, did anybody not put 8? Did anybody put nothing? Everybody added 8? Julian.
I just put a 2.
And then what charge did you have?
Plus 4.
Plus 4. So carbon, in the area of atoms and adding and subtracting molecules, if I'm going to use an analogy, is bi. It can go both ways. Twice the chance of a date on a Saturday night. It can add electrons. It can subtract electrons. It can act like a metal. It can act like a non-metal. It can do both. So if you have plus 4 and nothing there, you are also right. But then once you go over here, you have to add 3 minus 2, add 2. Now that shouldn't be 6. How did you get minus 2? What should that be? To be an ion, we need it either full or empty. So what do we do to that 6? I think I need to start asking people at random. I'm going to ask Caden. Where's Caden? Do you have the most points? Hold it. Yep. You're currently winning.
What?
You have the most points in the entire class. So the question was, they were all going along nicely. They did get the correct charge, whoever this was. I mean, I could go and look, but I'm not going to do that. How many, but you want it either to be full or you want it to be empty. So what do you do with that 6? Now I'm going to go for Kate.
You have to add to it, and then that makes it -2, so
Right. Fantastic. Notice then they all become their nearest noble gas. 2, 8, 2, 8, 2, 8, 2, 8. Now, noble gases don't do anything. They have a charge of 0 because they're useless. They're already stable, so they don't do nothing. That's why they're called nobles. They don't react to anything. They don't do any work. Lazy people. Now, this should have been 2, 8, 1. We got rid of the 1, became 2, 8. It's like the nearest noble gas again. Plus 1, plus 2, got rid of the 2. Got rid of the 3, became plus 3. Added it, we did minus 4 again. If you had 2, 8, and you got rid of the 4, because add 4, take away 4, about the same. What charge did you have there? Plus 4. And then we go 2, 8. Oh. This is missing something. What else should be there? Another 8. And then I'll continue on. 16 protons. Good. Apparently I can't write. So we have 16 protons, and it would be 2, 8. And normally it would be 2, 8, 6. Add 2, get our 8, and then it becomes minus 2. 17 protons. So 2, 8, 10. Put a 7 here. Add 1, make it 8, minus 1. And then you have 2. I should make commas in between those so it's not 288. 2, 8, 8, 18 protons. Again, a noble gas, and it's fine. Ions, to predict what charge they're going to be, ions want to get a full shell. Now you may notice that in here there are some that have more than one charge. There are also ones in here that have charges that aren't even on here. So for example, scandium here just says plus 3. But I also know that it can also be plus 1. So don't rely on this to say every possible combination. And the reason they have extra charges is their orbitals can play around with things. Jojo, can you put away the laptop? In your bag, you don't need it out. No laptops required. So now we're going to do Lewis dot diagrams. Yes. Please get out your periodic table. I'm going to teach you how to count valence electrons. You've been doing it. already. Now I'm going to just get it out here. Where is that one? And let's rotate. No, I want the other one. Go up. Other one. Perfect. And where's my app? Lewis dot diagrams depend on you being able to generate the amount of valence electrons very quickly. So I'm just going to go over how to count them so you can do it very quickly in your head. So I'm just going to ask your name, and you're going to tell me how many valence electrons. How many valence electrons in beryllium, please? Merhat. Two. Excellent. A number of valence electrons in fluorine. Anders. First date back on the hot seat already.
6.
Count again. How are you getting that?
You know, like the 4 on the 2 shells, and then the next one's like 8, so subtraction.
You're doing it a complicated way. Now, when you do the shells, they are mirrored in the periodic table. So if you want to do it quickly, like it goes 2 and then 8. So really, all you have to do is count 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. If you count from the row it's in, you'll always get the right number of valence electrons. Did I say oxygen? Fluorine. If you were answering for oxygen, you're right. I may have pointed at oxygen and said fluorine. That's okay. 6 was then right for that. Esther, number of valence electrons in silicon? 4. And Mick, number of valence electrons in chlorine? 7. And Pablo, number of valence electrons in fluorine? 7. Excellent. Oliver, where's Oliver? Excellent. Number of valence electrons in bromine?
7.
What about all those?
Oh wait, no.
No, I'm not going to be that cruel. I was hoping you'd give me the bigger number. You'd start counting. It is 7. It's 7. Does anybody know why it's 7? When you count across, you just have to count in a special way. You count across going 1, 2, 1, 2, skip a few, 3, 4, 5, 6, 7.
Oh, you skipped the...
You skip all of this.
Oh.
Yeah. And the reason being, did I show you guys that complicated diagram where I put multiple energy levels and I said this is quantum? This is actually the previous energy level. So if I said, how many valence electrons are there in scandium, you would say 3. But once it's full, it actually drops down in energy to the previous one and it disappears. So it actually leaves all the valence electrons. So bromine has 7, while zinc has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why a lot of these can do multiple charges. They have a lot more electrons to play around with. So once you're out of this area, they all have the same number of valence electrons in the family. So 7, 7, 7, 7, 7, 6, 6, 6, okay, 5, 5, 5, 5. But in here, play around a little bit more. This is why scandium, to become stable, it doesn't want to fill up this whole shell, so it can drop down to 3. But I know it has +1 because actually you could just get rid of that one, and then that energy level is empty too, but that's more Chem 11 considerations. So what I would like you to do now is draw the classic circle and dot Bohr model for sulfur, and then I'll show you the Lewis dot diagram. And I will ask a completely random person like Pablo to describe it to me. Yeah. I mean, it might not be Pablo, even though I'm saying his name over and over and over again. But it should be a completely random. Julian, you can't just fall asleep. Bring your periodic table. And a pen. And anybody else who's bored? I need to be able to. Oh, do you not even have your periodic table out? How can I do this quickly? Yeah.
I'm gonna go to the bathroom.
Okay. Yep.
Yep.
I'm going to teach you something very quick. Did you bring a pen?
Yep.
Excellent. We have said that this is like 8 energy levels. Have you learned S and P? Okay, energy levels are divided into subsections. Yeah. So have you learned S and P sublayers? So you can think of these columns as being the S. And this layer is being the P. And this there is actually a P. The counting starts at 1. This starts at 2. And this one starts at 3. So if I wanted you to give me the actual, not the Bohr diagram, but the quantum diagram, electron structure of, say, fluorine, I can give you a new diagram. I would say it's 1. S. 1, 2, 2. And fluorine would be, I'd go through and then I'd start over. This is the 2. S. And then I have the 2. P. 1, 2, 3, 4, 5. And so instead of being the valence electrons being 2 and then it's 2s2 because there's 2 and 7, it's actually 2, 2, 5. No, that's the first level. So number of electrons is there, and level of energy is there, so first and second. And then if you went down, you would get so 1s2, 2s2, 2p6, 3s2. This fits 6, just the 6 across. This fits 2. Yeah, we go to that. So 2p5. 1, 2, 3, 4, 5.
Yeah, it's in the.
And that makes sense because in this layer in the Bohr model it'd be 7, and it's now 2 and 5 and 7. And they're both the same energy because they have 2. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d all the way to 10. So that's actually the third level, but we fill it after the fourth. That's that level 3. Pardon? So no, this is fourth. That's third. This is fourth again. 2, 3, 4. Yeah. So, do you guys see that as well?
Yes, sir.
Yeah. And I can do a little bit more with that later. This is a little bit Chem 11. When we do some of the Lewis diagrams, see if you can also give the electronic structure like that as an extra puzzle. Okay. I can give you one off the side there, yeah. I have lots. And if I don't... Pardon?
Yeah, because that one's mine.
Oh, is that one yours? Did he bring you yours?
Yeah.
Julian, I appreciate it. That's really smart. When you're going to break something, break someone else's. Okay, Jennifer. Where's Jennifer? There's Jennifer. Jennifer, what should the Bohr model look like? First of all, how many protons should I have? 16 protons. And then how many electrons in, I'm going to run it around. How many electrons in the first shell? 2. How many in the next shell? 8. And how did you put them in? I saw with your fingers. Excellent. Oops. And then How many in the last one? 6. And how did you put those ones in there?
This part is like the second shell, and this part's the first shell.
Perfect. 2. I don't know if I'm mirroring it exactly or if I'm the opposite, but that's perfect. Did anybody do it like this?
Yeah.
Okay. It is wrong. I mentioned to you the bathroom stall method of electron movement. So this is like, there's a free stall. Why would I go in the stall next to them? I don't want to pee next to that person. I'm going to pee a stall over because we don't want to be paired together. But when they all fill up, they start pairing up.
So why are the ones on the inner shell together?
There's only 2 stalls.
Oh.
So even though it's big, and like you'd think, well, but it's actually more like 2 halves of a sphere. Because again, these are spheres, not actually circles. Okay? Does that make sense? Okay. Now the Lewis. I need you guys back because the Lewis is probably new, and we're going to join them up, although it's not going to be too difficult. The Lewis, you do exactly the same. This has how many valence electrons? 6. So it's an S. We don't need the number of protons. Your hand was up, Pavel.
I feel like 2 dots of the S, then 2 dots at the right, 1 at the bottom, 1 at the left.
Excellent. Have you done that before? You just knew it was. Excellent. That's the Lewis dot diagram for sulfur. We use it for showing bonding and moving of electrons because the only electrons that ever move are the what are these electrons called? Valence electrons. So we only want to see the valence electrons. And we don't need to count the number of protons once we know the valence electrons. We just need to say what element it is. So we go from this to this so we can show more bonding and we can show more activity and it's not as complicated. Because who cares about all that inner stuff? We only care about the active things, right? That's why we don't worry about the grade 8s. They're not real students. And then you became into grade 9. And grade 9 students are real students. They just don't count. Yeah. But now you're in the glorified realms of grade 10. You are real students with no leadership roles whatsoever. And just waiting for grade 11. Actually, this is a good year. If you can start volunteering in SAC, Omni Beat, Women's Society, there's a variety of different things. SAC is a big one. Anybody can help out at SAC because they just put on events. So if you can get in there and volunteer, show some leadership, now's the time to lay some groundwork and look for like house captain, assistant house captain, inner house captain, head prefect. Okay, give the Lewis dot. Now, I know these are different. This is where I would ask you how many valence electrons these have, but I already did that around the class. Which one of these are duplicates? I think oxygen, sodium is already up there. Anything else? Carbon. I is up there twice. There. So for everyone that's on here, just write out the Lewis dot diagram.
We don't do the crossed out one.
Well, you don't have to do that carbon because you're going to do that carbon. So just write them out.
Oh wait, I was that. That's like really high on chart.
Oh, one thing to realize early on in life. What element is that? What letters are they? Thank you, thank you. I meant, and not their fault. It's our typography. I met so many students that thought it was this. Yeah. The reason you should know it's not is because you can't have two capital letters in a row for symbol, so it has to be an L. But also, English is confusing in the way we do our letters is confusing. So that's a capital I, even though it doesn't do this. I've been thinking of converting everything into Comic Sans. Comic Sans, as much as people make fun of it, was made so that people can really distinguish the letters. Yep.
Do you showcase the outer shell as well?
You don't have to draw a ring, it's just the electrons in the outer shell. It's just the valence electrons.
But do you have like electrons and then electrons? Or are they all in like the same?
I'm going to walk over there because I don't think I am interpreting the question correctly. 1 second. I'm just going to write down the rest of them. 8, selenium, 9, fluorine, 10, phosphorus.
So like there's 7 electrons. So they do 2 and then like 4 like that, or do they all go in the same?
Oh, they all go in the same.
They all go in the
And
same.
you separate them first and then pair them.
Okay, but what if there's like what if it's like copper and
I
there's
will give
29?
you very easy. I'm not ever going to give you copper. Because you can't. At that point, we have to do the thing I was showing them where you read all 1, 2, 2, 2, and you start doing quantum. We're not going to do quantum.
Is that right for Cassie's?
Oh, I'm not going to tell you. I'm going to call you to the board. And then you do it, and then we're going to find out. But you're allowed to consult with those around you. I will say, you don't appear to do anything drastically wrong. No confidence. Let's see who gets to come up to the board.
Carbon. 6 minus 2. Wait, I've been doing all this now, just the mainland. Just a little.
Did I not give you your point? What's going on here? Oh, there we go. Toolkit, group maker.
7 minus 3 is 5.
Okay. There are 10 how many questions do I have? 10 elements? 10? So, group numbers 1 through 10. Write down your number. 11 through 14. Keep working and know that you're getting a little bit of a break because the random gods have blessed you. And Pablo's not even on there yet, so he's just like, good. I do what I want. Okay, everybody got their number? Okay, come do it on the board. Quickly, in another color, just go dot your element. 1 through 10.
What's 5? I can't read
Thanks,
that.
Dad.
What's 8? I haven't
So
done
leave
it
it alone.
yet.
Andrews, how you doing in terms of understanding the text? Excellent. I do find sometimes, even though you miss a lot, if everybody else kind of, you can gather from everybody else in the class and pick up, sometimes it can be a little faster.
Oh, never mind. So what I did. Good. Set.
I have a show and tell and I have a question to ask you. Apparently you might have done this more than me. Does everybody like my new lanyard?
Very
It's
nice.
lovely. It's chemistry and rainbow. Yeah. But when I ordered it because it looked huge. It came like down to here on the person. And then I realized, because I ordered it off of Temu, the models might have been a bit shorter than me. And then, because one student said, no, I've never ordered from Temu. They're safe, they're fine. And someone else said, I got hacked from Temu.
No, you're fine.
Is anybody ever gotten hacked?
You're probably fine. I've never even
How many of you have ordered from
I
Temu?
don't order from Jimmy.
And you were all fine?
Yeah.
Don't order from Panda Buy. I'm gonna say that person then told me it was just being hysterical.
I mean, like, to be fair, people does steal personal
Oh.
information from you. Like, they make you, like, enter emails and, like, fill in forms and they, like, sell your information.
Oh yeah, and there's a weird thing when I order from Temu. Like 2 days later, they say, "Oh, by the way, we're giving you all your money back in credits. Come click here." And I'm like, I don't know what kind of scam that is, but I'm not having any credits.
If I like spin a wheel and I always get like the biggest prize.
Yeah.
To like spend $50 and I get it free.
Okay, correct. These are a little spaced apart, but it's fine. Correct. Slightly wrong. I mean, number of electrons is all right. What? There's one quibble. Yeah?
On the right side, they are horizontal.
Yeah. Oh dear.
Oh.
But now I'll go group, ungroup, and then I'll go rescue him. Or her. Or they. Now this is fine. And that's a stylistic choice. You have to have them parallel just because that's one of the ways we do different things with them to do different things. So if you make it like that, you're kind of implying a bond, and we don't want to imply a bond next just yet. Okay. Good? Okay. Here's a bunch of stupid rules. The rules are good, but if I read through them to you now, it would just be confusing, so I'm not going. You can refer back to it after we do it. The only ones I really want you to pay attention to right now. One, we have a question. There's, hold it. Did I get one of them wrong? What's going on?
The I. Is that right?
2, 4, 6, 7. Yep.
Should be 7.
Yeah, how many do you have?
4.
Oh.
Why
Oh,
should
wait,
be 7?
you have to count from here. You have to count from 12. So it's 5.
You have to count all the way from the end. Let me bring it back up. Where'd my... So for I, go here, you go 1, 2, skip the inner transition metals. So 1, 2, skip a few, 3, 4, 5, 6, 7. Is that good?
It's not all the halogens. You're including some of the halogens. Okay. Just not these ones. Okay.
Good, okay. Okay. Here's the two definitions. Number one, this is just definite. If we have things that are like all those electrons that are paired that are by themselves, those are known as lone pairs. Then we have the octet rule. And this is for bonding compounds. Bonding compounds. Everything, except a million exceptions, wants to have 8 electrons in its outer shell. It wants to have a full set if they're bonding like with an actual covalent bond. I say families 14 to 17. It's actually only about I would say about 9, 10 elements actually follow the octet rule. And there's so many exceptions, but we're not going to do the exceptions. The only exception you need to know is that hydrogen, because it's in that first one that only needs 2 electrons, hydrogen only needs 2 electrons. But everything else wants 8 electrons. Yes?
Does that say bonding or boarding?
Bonding. Bonding.
What about lithium? Does that already need 2 as well?
Don't ask silly questions. The reason I say don't ask silly questions, yeah, except lithium is going to be involved in ionic bonding, so it's going to lose its electron and have nothing. So you're only going to have to worry about it when you make bonds. It's going to be covalent. Yeah, I'm going to give you one ionic example. I don't give that many because it's super easy, and it's the covalent ones where it's actually like a little puzzle. And this method is the complicated method you use in chemistry 11. It will always work. And it's really good when you have charges, especially for accounting for the electrons. Because then students don't ask silly questions like, which one of them do I take the electron from? You just do it. However, visually, there's a second method that's really good, and I use it all the time. I'm going to show you both. You can use either one. It's sometimes good to use one, and if you're confused, switch to the other one. So I'm going to start with the counting of the electron ones first. I'm going to start with a nice, easy compound, hot H2O, because we already kind of know what H2O looks like. And the first thing you do is count valence electrons, and I do that by putting them here with the amount. So I've got hydrogen, and I've got 2 of them. I've got oxygen, and I've got 1 of them. And then for my charges, what's the charge on this?
2.
No, there's 2 hydrogens. What's the
3.
charge? Nope.
4.
Nope.
No charge?
There's no charge.
Positive.
It's no charge. If a charge is not written, it's a secret 0. So there is no charge. There is, how many valence electrons does hydrogen have?
2. Oh,
1, and then 1 each. How many does oxygen have?
6.
6. So we have a total of 8 electrons. 2, put in central atom. And that is the atom that everything else is going to connect to. How do you know which atom is the central atom? Yeah?
I'm guessing the one with more electrons.
No.
Oxygen.
Not the one with more electrons. Doesn't have to be. I can think of a couple of exceptions.
There's less of.
The one there's less of. Because you often you'll have like a thing and then a bunch of things around it. So it's just the one you have one of.
What's the question?
Which is the central atom? What atom do you put in the middle?
Oxygen.
Oxygen. So in this case, it's going to be oxygen. And then put in outer atoms, in which case hydrogen and hydrogen. I'm going to give myself a bit more room because I want to show the accounting. My apologies if this has messed you up. And then 4, bond, and every bond is 2 electrons. Have any of you been at schools in like Germany or Switzerland or other Germany? You were. Okay, I'll show you something else as well that might make sense if you've seen this before. So you bond it. So you connect the outer atoms to the central atoms, and you know that those are 2 electrons. So now we start taking into account of these are how many electrons we have, and that's how many electrons we've used up. So we used up 4 in our bonding. We have 4 left over. Good so far? Yep.
Is that a 0 or an O? Oh.
Here, that's an O. That's oxygen. I'll put a little X there.
How do you use 4? There's 2 hydrogens.
Oh, no. I bonded
You
them.
counting those as 2? The lines as 2?
The lines are always 2.
Got it. My fault.
Yeah.
Brother.
Bonds always have 2 electrons
I just use dots.
on either side.
So oxygen still have 4 rest, right?
New.
Oxygen, hold it. Oxygen still has
4 electrons, right?
nope.
No.
Nope. These are just there's 4 electrons. I don't know.
Can I use the 2 hydrogens on one side?
Can you what?
They're like, do it like this. Like I use dots instead of the line.
Okay, you've made 2 tiny little hydrogens. No, make them about the same size. Atoms are really far apart, so that really distorts them if you do that. You can make them 90 degrees, but when you place the hydrogens here, you should use the like the north, south, east, west. You should put them in the coordinates. Right? Like if right now, if you were sitting there and you had this, that's fine too. But if you have this, that's a little weird. Separate them out into coordinates. Does that make sense?
Yeah, I'll make the lines.
Yeah. Okay. You also had a lot of X's and O's in there.
Yeah, I use dots.
No, stop that. Don't. No dots.
Okay.
No, I'll do that yet.
I'll use mine.
Yeah. I mean, you will later, but. Okay, we bond it. We account for the electrons. 5. Put electrons on outer atoms until out of electrons or meet octet rule. Do we then take these 4 electrons and put them on hydrogen? Does hydrogen obey the octet rule? No. It only is hydrogen happy right now? Yeah, it's got 2 electrons. Hydrogen has 2 electrons. That hydrogen has 2 electrons. It's fine. So you actually skip this step for water because hydrogen's fine. You don't need to put those electrons anywhere. 1, 2, skip a few. And then I'll go to the next one. 6. Put left over electrons on central atom. We only have 4 left over. And you would put them again in the coordinates. So 1, 2, 3, 4. And I'll get rid of that X for oxygen because that's just to show you that it's not a 0. And you're done. Now, you're not done, really. Because the next step, 7,
How many more steps are there?
check, so many. Yeah, I was at a room 2, but I just expanded my page. Check the octet rule. This is for all atoms. If good, done. Else, step 8. I'm just making up this. I write this slightly differently every time. Step 8, put in an extra bond with lone pair electrons. Repeat. And you stop as soon as you obey the octet rule. I'm going to add that in because that's going to come handy later when you're starting to do these on your own. I give you a little bit more complicated ones. Right now, it's pretty good because is oxygen happy? Yeah. It's got 2, 4, 6, 8. Oxygen's is 8. It's meeting the octet rule. Hydrogen's an exception. It's meeting its 2. That is water. And if you started off saying, okay, I've got oxygen, and I'm going to put it in the coordinates, and then you bonded it, and then you put on the lone pair of electrons, that is fine. And the reason why it looks different is because that is a 2-dimensional drawing of a 3-dimensional structure. This is what water looks like. But if you look at it dead on, it looks like they're on either side. These little strands are representing those lone pair of electrons. So when you see water drawn in things, they tend to leave those off because they're invisible. So that's why it works. But what charge are electrons? Negative. So they are repelling each other, and so it makes this 3-dimensional structure so that they're all equidistant, so they can get as far away from each other as they can because they absolutely hate each other. And when they do that, you get that structure. Now, if you drew it this way, you've basically drawn this. And that's also correct. We're doing it in the 4 coordinates because we're representing a 3-dimensional tetragon on a 2-dimensional page, so we're stuck with that. Yes?
Can you scroll to step 8, please?
Oh, yeah. I wanted to talk about it. And then, oh, you're going to love this. Now, as soon as you write those down, I'm going to do it again using a completely different method. but I think you'll like that method. I like both. This one is sort of like, the problem started to get a little complicated, so I pulled out a sledgehammer and hit it, and now it works. Whereas the other method is like a fine hammer, and you can like see the different parts, and it's easier to visualize. They both have their uses. Everything is just a tool. Is anybody still writing that down? When I said everything is just a tool, I remembered I put this picture here once. What does that mean? In fact, this is not a pipe. How many of you have seen this before, this picture? What does it mean? This is a famous painting.
Oh, this is not.
This is not a pipe. Is that a pipe?
No.
No. What is it?
Picture.
Is that a picture of a pipe?
Yes.
Is it? Or is it a bunch of LED dots that is imitating the original picture of a pipe? So it's not even a painting of a pipe, because the painting's somewhere else. So when we do all these models and they say there's more to, it's always a reminder. This is a famous painting because its purpose and the artist's purpose was to show things aren't what they appear to be. This is just a painting. And now when we have pictures of it, it's not even a painting. That's not actually a pipe. These aren't actually electrons. These are just our poor representations, and we have more than one method because everything in the end is just lies, but they're useful lies. Some of them allow us to make predictions, and we have evidence and theories, and some of them are just terrible. And sometimes we have more than one method. So here's the other method. Method 2. Pardon? Find room, pull out another page. Method 2, we have H2O. So in this one, I just take the elements and I draw them wherever I want. It is useful to set it up in a central atom kind of way, but if you don't, it's fine. And then I just do the valence electrons. I do the Lewis diagrams. How many valence electrons does hydrogen have? 1. So I put it in there. It doesn't matter. I could put it anywhere I wanted. I'll put 1 here. And then how many does oxygen have? 6. 1, 2, 3, 4, 5, 6. I find if you go around in a circle and you slowly add them, you'll never get that spacing, so now you're always right. And now you pair the lone electrons to make bonds. So every time you do this and you pair them, you have made a bond. And then you must redraw it. That is not the correct structure, but this is the correct structure. So those stayed, and now we have hydrogen bonded, and we can see they take up 2 electrons, and they do. Now, I saw it on Julian's page, and Jojo, you may have seen this before as well. It is perfectly acceptable to represent lone pairs as lines. If you've seen that before and you're used to that and you've done it before, that's fine. That is a German-Swiss scientist habit, and the dots are like a North American habit, and then sometimes they swap depending on who you've been trained by. I was trained with dots, so I tend to do it. But if you're trained anywhere else to do that, there's no difference. It's just style at that point. Good? Okay. So, do CH4. Because I've been talking a lot, and you've been sitting a lot. Should I make you do it at the board? People want to get up? No. Riley says no. Okay, I won't make you do the board right now. I will ask someone what it looks like in a second. Look what Mr. Snow got me. Sorry, I'm disturbing you. Man, just found it yesterday. It lights up.
Wait, these are all atoms though?
left my math homework.
Also, you left your math homework behind yesterday.
Yeah, I just realized that.
There you go, here.
Thank you.
Are we not
I'll
counting
be cooked
valence?
tomorrow and have that. Thank you.
Yes.
Don't they say you gotta let it
There's
cook?
4 valence. for
Yeah.
C.
CH4, do it.
Yeah. The valence.
Oh, we didn't write down the example.
Valence. Are we not
We
doing
should write down the
valence?
example. One of the methods at least.
So is it 4?
Yeah, it's my, sorry.
Is that okay, Jojo?
There's no real electrons drawn on, it's just C.
Because I'm gonna give you more, and you're gonna want somebody to refer to once I move this off, right?
Yeah, just do it.
Yes, I did.
How about I go
Alright, so basically,
Oh my god, wait, I can't.
Zoom? Can you read that from back there? Do you want to just come sit up here and just get it in?
Well, even if I write. Oh, I did it.
One of the purposes of notes is not that you have to understand it right away, but that you can refer to it while you're trying to work through it again. Okay, if you can get that down. Paolo, question? Can I? Oh, perfect, you're done. Grab a partner, do it on the board. Fine.
mine has like this.
Yeah. So, which was the central level? You're gonna, are you going to master's 10?
No, it's 4. My
What
bad.
happens is, now, it is good, isn't it? Because we're doing
I don't know if you
that.
have to-
That's what I do pencil for notes. So yeah, that's your central.
No, there's no
Good.
that.
Oh, I see. Now,
Oh,
which method are you gonna use for this one? Okay.
We come 4H.
Yep, so you gotta put that down 4 H's. Yeah, you can get it, absolutely. That would be better. You're gonna have to move them around. No. Now for the valence electrons on.
It's like
The dots.
It's you just have one valence.
You have a period table? So you can look up valence? Oh, you just know.
So just one valence. Not take, excuse me. So take one component.
Now, join up dots. So from the outer ones to the central atom, so you have 2 electrons per each one, and each one of those is a photon. Yeah, you do, but I tend to draw like a big loop, but you just draw a line from one dot to another.
It would just be like a loose height. It would just be like.
No, only from H to the central atom.
Oh, okay, gotcha.
That's okay. Yeah,
I would just get rid of the height.
yeah, and now redraw it with the bonds properly
If there was
placed.
no charge, like basically.
Like north, south,
height,
east, west,
like
yeah,
not even-
again, you don't want circles around it, so redraw it so it's nice, it's straight line.
I don't know, but I think it wouldn't work if it was H4.
Yeah, looking good.
Only draw it if it's possible.
And
Basically, only ask if it's possible.
oh, we started by counting
Might
like
have
six
been
electrons.
A1 or something.
Which is
Or like
what do I do?
Plus,
it's 2Fs.
no. So you have 4 there, and then you have 4 there, so what's your total? 8. Now how many electrons are in these bonds?
I just.
In each bond, how many bonds do you have? So in total you have,
We're done.
it's done.
Wait.
Yeah.
I
Oh, I'm not doing that one yet, because we can get to it.
don't get one. Can I get some help?
No,
Let's go.
I don't know.
nope, not helping with those are ahead of time.
Can we go through it?
I am gonna actually have you do some on the board in a minute. This is just the first problem. I'm gonna give you a bunch.
Alright.
And I'll put you in groups too.
I don't know if I'm doing something wrong. I probably should. I mean, I did. Yeah, I guess I should. Cease carbon chloride 4. Oxygen fluoride 2.
Go on page.
Sulfur oxygen 3. Oxygen.
You dual page display on.
Wait, is it 1 and 7?
Right? You're doing.
So do I write
I think
1
I'm
and
missing
7?
an electron.
Whatever you want, just 1 separate.
Sorry,
Wait.
okay.
Is that right?
Yeah, what does the charge mean? Oh, yeah. What do I do with the charge? It's plus 4.
That means that's missing an electron.
Okay, so it's
Jojo, I put 2 pages on so you can see that. Let me know when you're down to here and I'll scroll down.
Okay, I'm checking.
Okay. And maybe I could make it a little bit bigger from there, because I could do that. Is that good?
What does under by 4?
Oh, that's just a dash. Bond.
Because nitrogen normally has 5
Oh, hold it.
electrons. Plus 1 makes it to 4.
Because you are trying to read it from back there. Why don't I?
Wait, positive hydrogen has no electrons, right?
No, it's charged with double compound.
Oh. Oh, wait, so what do you, so you have to add the protons and neutrons? And subtract
What?
the number. Oh,
Hmm.
yeah.
Just like removes 1 electron from one from like.
Hmm.
One that doesn't need it.
Where's that really long one? Oh well. I don't have that. Yep. Yep. Do you have to ask?
Is your phone on the table?
Yeah, you just leave your phone.
Just leave your phone, and you're good. So each bond is equal to 2 electrons.
Noof, can I, for this last question, are you like telling me to bond all of them?
Wait, okay. Oh yeah, I can get something.
Okay, well, I don't.
1 second. You're up ahead. Not everybody's there, so I'm just going to leave it till I get there. You can work with others who are also up ahead. See if you guys can figure it out. It's a puzzle.
Well, I'm struggling.
For methane,
No, this one. I think I just said one.
you will be required to know what this molecule is called. It has a completely different naming system. It is in the organic section of naming system.
Carbon.
But this is the only one we do. There's actually methane, ethane, propane, butane, pentane, hexane,
What does that mean?
heptane, octane, nonane, and decane. But you only need to know this one. This is methane. Okay, methane gas. It's that. Okay? Now, I'm going to do both methods here. If I had that, I would go carbon, 4 hydrogens, and what's its charge? Its charge is 0, so that's not going to change anything. Carbon is 4. Those 4 hydrogens have 4, so I have a total of 8 electrons. I put the carbon atom as the central atom, and I put the hydrogens around it in the 4 corners of the compass. Then I bond. 2, 4, 6, 8. That used up all of my electrons. I have no more. However, is hydrogen happy?
Wait, I think I know.
Yes.
Yeah. Is carbon happy?
Yes.
Yeah, so you're done. We don't have to do anything else.
Yeah, no, I know.
If I did it the other way, without the accounting method, if I did carbon, 4 valence electrons, and then hydrogen, now it often helps if you put the hydrogen with its valence electrons around the central atom, because then you can see the bonds. And then rather than making big circles, I'm just going to join them up. That made a bond, so that's 2, 2, 2, 2. This is not your final answer. That's messy. And a line means 2 electrons. A dot means electrons. So if someone misinterpreted that, they would think there's 4 electrons per. So you do have to redraw it. So we'll redraw it. Carbon, properly bonded to its 4 hydrogens. Is that good? Okay. Now, on your sheet, I'm going to flip over a second, and then I'll flip back. We've got NaCl.
This isn't.
Is that a covalent bond? What kind of bond is that? Ionic. So for that one, I would like you to draw Na and Cl as their Bohr model, and then you have to move electrons correctly, and then just show their charge.
Can NaCl not be a covalent bond? Do they not fit?
Pardon?
Oh, wait, no, covalent bonds are only between metals.
Yeah.
Oh, it's my fault.
Jojo, do I need to move it down?
Is that right?
What is that yellow mark?
What is that there?
Yeah.
Oh, check octet rule. If good, done. Like you're done. Else, step 8.
Oh,
Step 8.
so it's like slept.
Yeah, slept 8. I'd like to sleep 8 hours. 8. Put in an extra bond with lone pair electrons. We haven't even gotten to an example like that, but I wanted to put the rule in. Yeah? Hmm? Draw the two, put in the two, give the Lewis dot diagrams for both of them, Na and Cl, separately. And then you may have to move an electron. That's all you need to do right now. Yep.
It's just draw it, right, draw the two is like the ion, like with the quick one. I think.
Ooh.
Yep, with a quick one.
Where is? What time is this class in?
35? I think it's 35.
No.
35.
It is 12, isn't it?
No,
30,
55.
it's 35.
55.
What class do you have next?
Bad.
Oh, that's easy then. Because we're using English, so you would volunteer to stay here.
I would.
Socials.
I do not want to fill up the social studies. Which one's this?
Oh, for that one is not. Just do them separately as they're
Oh, see,
No, it's not available.
NA and then
like
do
this.
CL.
I was using this. It's like A.
The bonding just give that direction.
Just, yeah, just however many.
The one is share like this.
And then I'm going to come back to it.
The other one is like, oh, I have 5 and you want 5 more, so I'll give you my 5. So
Is that right?
literally gonna give the electron away. And this.
No, you won't.
Just get it, you
You
just
have
have
to
to
use
draw
dots as well.
like
Yeah, you said isn't it? Like,
both of them, like
Yeah.
in their
yeah, no wonder it's easy.
like
Wait, so they don't share this?
they don't share it, they just like have their own.
Wait, or is it just like this? Like,
It's like this.
And
One
you
has
can see those bonds.
and one has
makes a lot more sense.
the
Let's
sodium
do this
gave
one.
one electron
And
to the
just put it together.
it'd be like this.
Which method do you
Oh, that's right,
use?
'cause these
How
ones
many
are just like
electrons put it all together, or
This?
were
Yeah,
you
it's just like that.
Yeah.
So you just draw like this.
Oh, okay. Start off.
They're two
Which
different,
one is
they're not
essential?
bonded.
Oh.
Okay, I'm just gonna pick this
I
one.
think
I'll take it.
Which one do you prefer?
I'm stuck on
I think so.
this carbon dioxide.
How many hydrogen?
You can just write it like this is not here.
Because I have 8 electrons, I'm really
They're
good.
by themselves.
So you, whenever there's no number, there's an invisible one. So there's one carbon. So put the one you have only just.
And also, it's 8 so we have, right?
With the hydrogen
Should look
around
like
it,
this.
you're putting
The sodium C4 has electrons. So they know what the full armor shell is.
Carbon's happy.
Exterior electrons.
you got now, yeah, four benefits. Now just
Oxygen's not happy.
This one away.
It's what 7.
And this one. And then this one needs one.
So we forget about this?
Yeah, kind of just forget about it.
Like, unless
Now, carbon had four
A
benefits.
bond.
One, so give them each one electron.
what do you do?
How do you give them?
Wait, what? Oh, I did something.
Now, when
Yeah,
you do that, you take your lone electrons.
How does that?
How do you do
And
this?
you combine them with the lone electrons.
No,
It's not.
this is covalent, but you have, because
Yeah, no,
it's
And you can also
two
got
electrons,
okay,
should
you
not
need
be
to do it
existing.
as lines too, but.
Well, I it's
Six, right?
Why does? Imagine.
No, you're not.
You should have
Now you know you have one and two filters, and you know where they're.
But then that means that if you follow the steps that you
They
said,
drop straight
then
line.
Yeah.
How'd you get 7?
could use both electrons,
Oh wait,
all
that's
the
a different.
electrons
That was a
in
different.
carbon
I think
to make the bonds. And then oxygen in each of these electrons.
That's the,
no, see, carbon is 2 extra ones.
it's been
Now, the
8
only thing I
years.
added up
It used to be
there
so
is that is called
pleasure.
method.
How many is it more?
But it's 8 years.
M-E-T-H-A-N-E. And you will have to
Oh, it's zero.
eventually.
How many zero? Yeah.
Yeah, so it's actually,
So don't you
you
just
make
use?
carbon as 0.
This molecule.
What's carbon? Carbon is.
Yeah.
Oh,
Oh wait, no,
that's
carbon can. Oh, you're right. Carbon
You
can.
can
That's
lose,
one.
you can lose zero, so it's actually
Carbon
positive.
is 0, and then all of these
Just check yourself.
have 6.
Now for this one,
Yeah, it's
you,
tough.
now this one is not the same, right?
I'm saying yeah to this, but yeah.
So we just do it a little differently.
This one
Just
has
one down. Do, just write any there.
For living in Mexico.
Like, I thought I did it right now.
How many bands do I need?
Nitrogen squared, it's like this.
Nitrogen squared. It's nitrogen oxide, nitrogen
Well, actually,
Now put in its
I use that.
Actually,
perfect. And now you're done.
And then if I use 2, I have 8. I get 1.
Oh, I'm gonna start from there. Okay. This
It's impossible.
is not the same as the other examples
Can you do double bond?
because this is covalent. But what kind of thing is this? This is ionic. How do we know it's ionic?
I was just gonna highlight
How do we know it's ionic? Does anybody know how we know?
Because it's a non-metal of the metal.
It's a non, so if it starts with a metal and you have a non-metal, that metal gives you its ionic. If it's a non-metal and a non-metal, covalent. However, bonus marks. Can anybody give me an ionic compound made out of entirely non-metals? I think you named one last year, possibly.
Only non-metal.
Only non-metals.
And ionic.
In ionic.
Boron, carbon.
Carbonate.
Pardon?
Carbonate.
Carbonate would, that's just one ion, and it's actually all covalent. Pardon? Ammonium chlorate would work. I'm going to say chloride because it's easier to do. So ammonium chloride is covalent because NH4 plus and Cl minus. So an ionic bond is just positives attracted to negatives. Most of the time the positives are metals, which is why this works. But you will encounter some other ones in which it doesn't work. So it's not a unbreakable rule, it's just more like a rough guideline, like the pirate code. Okay, I'm going to go back to my single page view. There we go. Oh, and it's way too big. Zoom, page width. So we do them a little bit differently if they're ionic. What we need to show here is electron transfer. So we go NaCl. How many valence electrons on sodium? 1. How many valence electrons on chlorine? 1, 2, 3, 4, 5, 6, 7. And then we take, they don't share, they transfer. Empty shell, complete shell. Holy cow. I hate it when I do that. The board is so sensitive if I just lean close to it. Hold it. Where'd it go? Like seriously, where did you go? Did I delete it?
Hit undo.
Yeah,
Edit. Undo delete page. Yeah. It's the power of my shoulder. And then how do we show that something, if we move this electron, what happened to this element? It disappeared. What new property does it now have?
it's stable.
Pardon?
It's stable.
It is stable. Before it was an atom, now it is an ion. What charge does it have when we take away an electron?
Positive 1.
Positive 1. So we use the square brackets. Plus 1,
Oh, we just draw the Lewis dot?
minus 1. That's it. For an ionic one, it's really easy. You just draw the Lewis dot, move the electrons around, done. No bonding. No bonding. The bonding in ionic is the charges, opposites attract. Just so you know, that is only true in chemistry, apparently. Due to all the dating apps, companies now have so many points of data. All those ones that try and get you together with another person, they now know who got married, who broke up, who eventually got divorced and went back on their app, what your interests are, because you tell them who you selected on. It turns out the more interests you have in common, the more likely you are to stay together for longer. So you need something in common. Opposites only attract in chemistry and rom-coms, because movies don't want you to be happy. Okay. All these other examples are covalent. I would like you to do question number 3, number 4, number 5, and number 6. Right now. Right now.
Are they the same Mr.
Hold it. Isn't it? I really think it goes till.
It goes 45.
But I want it to go.
I swear, does that go to 55?
No, it goes 45. 55 is the next class starts.
No. Your next class would end at 1. Third block?
Yeah.
Yeah. I bet you're really sad it ends at 45. Okay. No, 1 second. This is important. For your quiz next week, I am going to post a review worksheet on the Google Classroom. And I will also later post the answer key. I'm not giving it to you mostly because I opened it up and I converted it from another file format and it messed up the symbols, and I'm just fixing it in latex. So, I'll post it. You can get started on it tonight and prep. I will have it ready Monday and Tuesday if you want a physical copy and you didn't do that. Yes?
What day next week is this?
Pardon?
What day next
It's usually Thursday or Friday. Whichever day we have class on.
Thank you.
Sometimes Saturday if it works, but usually Thursday or Friday.
Thank you, Mr. Greenfield.
You're welcome. We will practice more Bohr models next day.
Is that homework?
I would do some of those for homework. Practice for your quiz next week for homework. You don't, I should qualify, you don't have to do all of them and be worried I'm going to mark it, because what we're going to do is come back in and have you do some of them at the board. So some help in figuring them out. There's some curveballs in there. I don't expect, it's not an expectation to be able to get it all right away, but a lot of people got it right second or third try once they were fiddling around with it.